Hi guys, here is lesson 95. It's called Combining Rational Expressions with Unlike Denominators. If you'll remember, rational expressions are fractions that have variables in the denominator. So these are going to look ugly, but we're trying to simplify them by adding or subtracting to get something not as ugly. So when we add or subtract fractions, even if they have a bunch of variables in the denominator, treat them like regular fractions. If we added or subtracted 1/2 and 1/4, we would need to rewrite 1/2 so that it has a denominator of 4. So if we look at question 1, all it wants us to do is find the LCD, which stands for least common denominator, for each expression. So anytime you have these, you're going to want to factor as much as you can. I can't factor 5, I can't factor x minus 2, I can't factor 6, but I can factor this denominator. So to make x squared, I have x times x, and to make 2, I have 2 and 1. I want a -1 in the middle, so I'm going to have a -2 and a +1. So if I rewrite this, I have 5 times x minus 2, and eventually I'm going to add that to 6 over x minus 2 times x plus 1. Now all this question wants is for you to find the least common denominator. So to do that, I need to see what they have in common and what they are missing. These both already have an x minus 2, so this first fraction is missing this x plus 1. In order to make the denominators equivalent, I will need to multiply this first fraction by x plus 1 over x plus 1, because remember, x plus 1 over x plus 1 is just a weird way to have something equal 1, and when we multiply 1, it doesn't change the value of what we started with. Now, this question doesn't actually ask me to do any math. All I have to do is write down the least common denominator. So the LCD for these two fractions is x plus 1 times x minus 2. All right, here's a different example, letter B. I have two really funky looking things here. I can't factor either of my numerators, but I can factor my denominator. To make x squared, again, is x times x. And I need to make 15 when I multiply, but when I add together I get 8, so that's going to be 5 and 3. So it's x plus 5 and x plus 3. All right, if I look at this one, I can take out a 5 because they both have a 5 in common. So I can rewrite that as 5 times x squared minus 100. And if you remember, this is a difference of squares. X squared is a perfect square, and 100 is also a perfect square. So this is really like 5 times x minus 10 times x plus 10. If I FOILed this, I would get x squared plus 10x minus 10x minus 100, and these middle things would cancel, which leaves me with x squared minus 100. All right, so now I have something super duper ugly for my denominator. So I'm going to rewrite all of this so that I can keep track of it. So I have 3x over x plus 5 times x plus 3. And eventually I would be adding that to 4x over 5 times x minus 10 times x plus 10. Now you might notice that I have literally nothing in common between the two denominators here. Luckily this one, again, only wants you to write down what the least common denominator will be and not actually do the math. So notice that I need to multiply this first fraction by everything in the denominator of the second fraction, and I need to multiply this second fraction by everything in the numerator of the first fraction. So it doesn't actually matter what order I write this in, because when I multiply, the order doesn't matter. So my least common denominator is going to have a 5, and I'm going to be multiplying by x minus 10, and I'm also going to be multiplying by x plus 10, also by x plus 5, and x plus 3, which is a ridiculously complicated denominator. So thank goodness all I have to do is write down what the denominator would be. All right, so what if we want to do this and actually add the fractions together? Again, this is going to take quite a bit of work, so make sure that you have some paper nearby so that you can follow along and get your own answer as well. All right, so the directions for this example is going to be to add. So I have 3x squared over x squared minus 9, and eventually I'm going to add that to x plus 2 over 4x minus 12. All right, so I'm looking for what I can factor. Well, I know this is a difference of squares, so if I factor it, I get x plus 3 and x minus 3. This one I can take a 4 out, and so I'm left with x minus 3, because 4 times x is 4x, and 4 times negative 3 is negative 12. All right, so I'm going to rewrite this to keep things straight. 3 x squared over x plus 3 times x minus 3, and I'm going to add that to x plus 2 over 4 times x minus 3. All right, well, this denominator doesn't have a 4 in it, so I'm going to have to multiply this whole fraction by 4 over 4. And this denominator is then going to be missing this x plus 3. So I'm going to multiply this whole fraction by x plus 3 over x plus 3. All right, when I do that, I don't actually want to FOIL anything out yet because I want to make my life easier. So 4 times 3x squared is 12x squared. And my denominator, I'm just going to rewrite them in the hopes that I'll be able to cancel something at the end. And then x plus 2 times x plus 3. Right now, I'm just going to leave it as it is. And my denominator, I'm going to do the same thing. X minus 3, x plus 3. All right, so now I have common denominators so I can add them together. Since I have 12x squared over here, now I'm going to want to FOIL this when I'm adding them to combine everything. So I have 12x squared, and I know what my denominator is going to be. So I'm just going to rewrite all of that down. And now I'm going to FOIL this. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. If I combine like terms up there, I get 13x squared plus 5x plus 6. And that's all over 4 times x plus 3 times x minus 3. All right, so now I have to figure out if I can factor my numerator to cancel things out. The nice thing about this one is that they're both plus signs, so I only have to try a few things. How do I make 13? Well, that would be 1 and 13. How do I make 6? That could be 1 times 6 or 2 times 3. Now, because I'm adding all of this, there's nothing that I could multiply between these to add up to 5, which means that this numerator is actually prime and I cannot factor it. So I'm going to stop here as my answer. That was quite a bit of work, but technically you didn't learn anything new, right? So when it asks you to add and then simplify, we have simplified as much as we can. All right, let's try another one. This time we're going to be subtracting. So I have 2x over 4x plus 16. And I'm going to subtract 3x minus 4 over x squared minus 16. I can't factor my numerators. I can factor this denominator. If I take out a 4, I'm left with x plus 4. Here, again, a difference of squares. So I get x plus 4 times x minus 4. Now, if you want to, you can reduce first before you do anything else. Notice how I have a 2 and a 4. I could cancel this out because 2 goes into 4 twice. So if I rewrite things, I'm left with x over 2x plus 4, and I'm subtracting 3x minus 4, an x plus 4, and an x minus 4. All right, this fraction is missing the x minus 4 part, so I'm going to multiply by that. This fraction is missing the 2 part. So I get x squared, if I multiply this out, minus 4x. I'm going to rewrite my ugly denominator, just how it is, no multiplying necessary. I'm subtracting, if I distribute this 2, I get 6x minus 8 over 2 times x plus 4 times x minus 4. All right, so now I'm going to be combining like terms. My denominator is going to stay the same because that's what happens when I add or subtract fractions. And I have to be really careful about this negative sign here. So I have x squared just over here by itself. And now here's where it gets tricky. I have negative 4x minus 6x, which is really negative 10x. And here I have a negative 8, which is really like adding 8. All right, this I'm going to look at to see if I can factor. Because it's an easy number here with the 1 and the 8, that's a good sign, right? So let's see if we can factor. how do we make x squared? Well, it would just be x and x, right? And how do I make 8? I need to get to 10, right? So let me see, 4 times 2 is 8, but if I FOILed this, let's see, 4 plus 2 would be a negative 8. Yeah, that wouldn't work out so well. What if I had, oh, sorry, 1 second, guys. If I tried 8 and 1, 8 plus 1 is only 9. So this is prime, which means I can't go any farther. I'm going to stop right here. All right, let's try one more addition one, and then I will leave you to your own devices. Example 4 will be negative 24 over 32 minus 8x plus 4x plus 1 over x squared minus 7x plus 12. All right, first thing I'm going to do is rewrite this denominator as a negative 8x plus 32 to make my life easier. So I can factor this. If I take out a negative 8, I'm left with x minus 4. And here I have x times x. Let's see, 3 plus 4 is 7. If they're both a negative, I would get negative 7. Negative times a negative is a positive 12. So that's a good sign. I can simplify right now. I know that negative 8 goes into negative 24 3 times. 8 times 3 is 24. So I have 3 over x minus 4. And I'm adding 4x plus 1 over x minus 3 times x minus 4. This fraction is missing the x minus 3. So if I multiply that, I'm going to distribute this because I'm going to have to combine them at the end. So I get 3x minus 9 over x minus 3 times x minus 4. And I'll be adding 4x plus 1 over x minus 3 times x minus 4. Because I'm adding, my denominators are the same. I can just write it down. All right, if I have 3x and I add 4x, I get 7x. I have negative 9 plus 1, which would give me, whoops, not positive 8, which would give me negative 8. I can't factor that because it's not a trinomial, so this is my final answer. If you would like some additional practice, please check out lesson practice on page 634. Thank you.